Hello, welcome back to the channel and welcome back to this series on gradients. So in the previous 8 episodes I've explained what a gradient is and how to find it using differentiation and the rules for differentiation that are useful and come up in the A-Level syllabus. So today we're going to start looking at why finding the gradients and why differentiation is actually useful and what it can be used for. So today I'm not going to do a real world example, but what I am going to use is I'm going to use differentiation to find the maximum and minimum. So I've got 2 examples on the board. One is a graph of y is equal to x squared, which we know is a U-shape, and we're also going to do y is equal to the minus of x squared. And notice I've taken the minus outside of the bracket, and in this case the graph is the upside down version of this one. So we know from this graph that this will have a solution at 0, the minimum point on the graph is 0, and on this point the maximum point on the graph is at 0 as well, and the x-coordinates of which those occur is also at 0. But the beauty of differentiation, it allows you to find it for any function, or for most functions. So, at this point here, and let's do it in red, at the minimum, it's known as a turning point. So along here, the gradient, so dy by dx is equal to 0. And the same for this point here. Which means that we can use this to find the turning point on the graph in terms of x-coordinates, which we can then replug into these equations to find the local minimum point on the graph. So the way this is done is if we to do dy by dx of this, from our rules of simple differentiation, this is going to be equal to 2x. And we know that at a minimum or maximum, this is going to be equal to 0. Which means this is going to give x is equal to 0. So we know that one of these turning points is going to be at x equals 0. And I can do the same for this, and hopefully it should give the same answer. So we got dy by dx is going to be equal to minus 2x, which again is going to be equal to 0, and therefore, again, in this term, this is going to be when x equals 0. So again, this is going to be the turning point on the graph. If we didn't have the graphs plotted, or we didn't know what our function looked like, the question is, how do we know whether it's going to be a minimum or a maximum? So for this, the method is we differentiate this again. So we go dy squared by dx squared, and if we differentiate this, we end up with the number 2. If we differentiate this again, so we got d2y by dx squared, this would give the answer of minus 2. Normally with most functions you'd actually end up with an extra x term in this, in which case we have to put in our minimum value of x into this. But what you can see between the differences between these two is that the second differential of this is a positive number, and in this case it's a negative number. And this gives us the actual rule that when we have a minimum or local minimum and we find the double differential of it and we put in the x-coordinate of that minimum, we end up with a positive number. So positive number of the double differential is the minima. The double differential of a maxima will be a negative number. So that's how you can find whether it's a maximum or a minimum. There is another form of turning point that we'll do in the next video, which is called an inflection point, and as I said, we'll go through that in the next video. Anyway, thank you for watching, please hit the subscribe button, and I look forward to seeing you in the next video very soon.